Hello, good day. How are you doing? I hope you are good. Okay, still dealing with heat and temperature. Today, we shall be treating another topic, specific heat capacity and heat capacity. To understand this topic very well, I want you to remember, as we stated earlier, that rise in temperature is proportional to the quantity of heat supplied to the body. There are also other determinants which determine the rise in temperature of a body. We have the mass of the body and we have the nature of the body. Thus, we have H is equal to mc theta. While theta is the rise in temperature, that is the final temperature minus the initial temperature. H is the quantity of heat supplied to the body. M is the mass of the body, and C is a constant which you know as what? Specific heat capacity. And it is dependent on the nature of the body. So, the temperature rise of a body is proportional to the quantity of heat supplied to the body, the mass of the body, and the specific heat capacity of the body. What is this specific heat capacity? It is the amount of heat energy required to raise the temperature of a unit mass of a substance by 1 degree Celsius or by 1 Kelvin. That is the amount of heat energy in joules which is required to raise 1 kilogram of a sample by 1 Kelvin. What does it mean? Which amount of heat is needed to just raise a sample, that's 1 kilogram of the substance? So let's assume this is a pot of water and we have a pot of oil, 1 kilogram of mass, and then we apply heat beneath and we insert our thermometer. It was initially at 20 degrees Celsius, 20 degrees Celsius. So what's the specific heat capacity? It is the amount of heat that will be needed to raise this thing from 20 degrees Celsius to 21 degrees Celsius. I'm talking about what? 1 kilogram mass. That is 1 kilogram of the sample. So if here maybe we need, let me say 30 joules, and here we need just 15 joules. Here we need 15 joules to raise this 1 kilogram of sample from 20 degrees Celsius to 21 degrees Celsius. And here we require just 30 joules to raise it from 20 degrees Celsius to 21 degrees Celsius. So in essence, specific heat capacity is simply the amount of heat needed to raise just 1 kilogram of a substance by 1 degree Celsius. Understand this. Substances which have high specific heat capacity takes a very longer time to get heated up or to get cooled, because it takes a larger amount of heat to raise just 1 kilogram of these substances by 1 degree Celsius. Then to get the SI unit of this specific capacity, have that if H is equals to mc theta, while C is our specific capacity, so C will now be making C subject of the formula to be H over m theta. Remember here, H is our quantity of heat, M is our mass, while theta is our what? Change in temperature. So to get the SI unit, heat is in joules, M is in kilogram, while temperature is in Kelvin. Therefore, the SI unit for specific capacity is joule per kilogram per Kelvin. Water has a very high specific heat capacity of 4,200 joule per kilogram per Kelvin. You can have this offhand. That is the reason why we mostly use water as a temperature regulator, because it takes a very high amount of heat energy for water to have a temperature rise. If we have known our specific heat capacity, which we say we can designate with the sign C, then what about heat capacity? It is designated with the sign Cp. So, by definition, heat capacity is the quantity of heat required to raise the temperature of a body by 1 Kelvin or by 1 degree Celsius. Again, heat capacity of a body is the quantity of heat required to raise the temperature of a body by 1 Kelvin. Note this difference. While specific heat capacity is required to raise the temperature of just 1 kilogram of a body. That's a unit mass of a body. Heat capacity is the quantity of heat needed to raise the whole body by 1 degree Celsius. For instance, we all know that water has a specific capacity of 4,200 joule per kilogram per Kelvin. That is for 1 kilogram of mass. Then, if this happens to be a pot of water, this has 5 kilogram mass, while this has 3 kilogram. You see that if 1 kilogram of water needs specific capacity of 4,200, therefore 3 kilogram of water will now be 3 times the specific heat capacity. The same way, that of 5 kilogram will now be 5 times the specific heat capacity. In essence, heat capacity is simply the mass multiplied by the specific heat capacity. This gives you your heat capacity. That is the reason why it will take a higher amount of heat to raise 5 kilogram of water than it will take you to raise 3 kilogram of water by 1 degree Celsius. Alright, if you agree that heat capacity is equal to mass times your specific heat capacity, therefore Cp is equal to mc. We can therefore substitute this equation into the final equation we have, that H is equal to mc theta. You can see that this mc theta can now be replaced with what? Cp. Thus we have H, which was initially mc theta, divided this mc theta by Cp. Since we've agreed that Cp is mass times specific capacity, therefore H will now be equal to what? Cp theta. So we therefore have this formula, and then we have the formula that says that C is equal to H over N theta. Then to get your SI unit for specific capacity, we can simply state that if Cp is equal to N times specific capacity, which is kilogram, times, remember our unit for specific capacity, which is joule per kilogram per Kelvin. So dividing this, so I left it what? Joule per Kelvin. Therefore, our SI unit for heat capacity is joule per Kelvin, while the SI unit for specific capacity is joule per kilogram per Kelvin. While our specific capacity is not dependent on mass, heat capacity is dependent on mass. We have the first question here. What is the quantity of heat required to raise the temperature of 300 grams of aluminium cube from 30 degrees Celsius to 70 degrees Celsius? Given that the specific capacity of aluminium is 900 joule per kilogram per Kelvin. From this question, we are asked to find what? The amount of heat. Remember the formula for heat, which says that H is equal to mc theta. So you can see that from here, we are given our mass, we are given specific capacity, and we are now given what? Temperature change. So all we are asked to find is just heat. And then we can see from this SI unit, the mass is in what? Kilogram. While we are given our mass in the piston in gram. So you can simply convert this 300 gram to kilogram. Converting 300 gram to kilogram, you divide by 1000, that gives you 0.3 kilogram. So substitute the things we know into the formula. Then don't forget, our temperature change is 70 minus 30, that's theta 2 minus theta 1. The final temperature minus the initial temperature, which is what? 40 degrees Celsius. So we are going to substitute this thing we have into the formula for us to find our what? Quantity of heat. Therefore, H is equal to 0.3 times 900, which is our specific capacity, times 40. And this will give us 10,800 joules. Therefore, 10,800 amount of heat is required to raise 0.3 kilogram of aluminium cube from 30 degrees Celsius to 70 degrees Celsius. If you're familiar with the formulas we've derived so far, let's try this second question. If the specific heat capacity of copper is 390 joule per kilogram per Kelvin and its heat capacity is 585 joule per Kelvin, find the mass of the rod. Here we are given specific capacity and we are given heat capacity. So you can guess what's the formula we're going to use since we're asked to find what? The mass. You can't possibly be using H is equal to mc theta, because here you're not giving what? The change in temperature, you're not giving the amount of heat, you're only giving specific capacity and your heat capacity, and then you're asked to find what? The mass. So guess what formula we're going to use? You can see we're going to use Cp is equal to Nc. So if you have this formula, you can see it is very easy. Since you have the specific capacity and we have your heat capacity, only to find what? The mass. So our mass from here will be Cp over C. So substituting into the equation, we have capacity as 585 over our specific capacity as 390. So if we divide through, we now left with mass equal to 1.5 kilogram. So the mass of this copper rod is 1.5 kilogram. So you can see, to solve this thing, you have to be familiar with the formulas. The one that states H equals to mc theta, C is equals to H over m theta, Cp is equals to mc, and H is equals to Cp theta. These are the 4 important formulas which you shouldn't forget while solving your specific capacity and your heat capacity. So friends, if you have actually understood me that a substance or a body which has high specific capacity will take a longer time to heat up, because it takes a longer time to raise just a unit mass of that body, such as water and oil. So it takes a longer time to heat up water than it takes to heat up oil, because water has a higher specific heat capacity than oil. Also, if you have understood that why specific heat capacity is not dependent on the mass, since it's just 1 kilogram, that's 1 unit mass, heat capacity is dependent on the mass. If the mass increases, it means that higher amounts of heat will be needed to raise that particular body. So if you're on the same level, can you help me solve this evaluation? The liquid A has specific capacity higher than B. Which liquid can be used as a coolant in car radiators? Again, a particular liquid A has a higher specific capacity than liquid B. So my question is, which liquid can be used as a coolant in car radiators? One, we have A, B, both can be used and none can be used. Take your time, go through the question, understand it, and then as usual, you can type in your answer in the comment section. And don't forget, if you have a question, don't hesitate to type it in the comment section as well. Thank you so much for being with me, and I hope that you also join me in the next session.